All right, guys, so now the thermophysics. To understand thermophysics, we have to dive into the states of matter. Now we know there are three states of matter for solid, liquid, or gas. To memorize this, you have to simply think about the intermolecular forces. The stronger the molecular forces, the greater the attraction forces. So the smaller the space is going to be for the solid, and that's going to only make them vibrate about a mean fixed position, which is going to give them a fixed volume and a fixed shape. And of course, they're going to make them incompressible. As you can see, the arrangement are in a perfect shape with little or no spaces between them. For the liquid, they've got a strong force, so therefore the spaces are medium or loosely packed. They can slide over each other. They take the shape of the container, though they have a fixed volume. We say they are slightly compressible, so we use them in hydraulics, and therefore it gives you this arrangement with a little some spaces between them, so they're able to slide over each other. In the gases, the intermolecular forces are very weak. They tend to have very large spaces. They move randomly and rapidly in all directions. They don't have a fixed volume or a fixed shape. So they are compressible because they have very weak forces. We can compress them in a cylinder, and therefore the arrangement, they are spread and they do not have any forces between them, so the spaces are very large. All right, so that's the main idea of states of matter. Now moving on to the idea of Brownian motion. Now Brownian motion is basically some dust particles are moving in random zigzag motion. Why? Because they're being by speedy tiny air molecules that makes them move in a random zigzag motion. You need to understand it's a zigzag motion. They also can provide you with a microscope, and that microscope is looking into a liquid with some pollen grains, and these microscopic pollen grains are being hit by the water molecules. You cannot see the water molecules, of course, so these water molecules hit the pollen grains and make them move in a random zigzag motion. Okay, so that's the main idea of Brownian motion. Now moving on, we move to the idea of temperature. Now, temperature is very important concept to understand, that it's the measure of the average kinetic energy of the molecules. So the higher the kinetic energy, so the higher the temperature, sorry, the higher the kinetic energy. Okay, if you increase the temperature, you increase the kinetic energy. You decrease the temperature, you decrease the kinetic energy. All right, so we've got two scales that we're going to talk about. The Celsius scale, so it rounds it. It's a scale that is from negative to positive, of course, but we don't really use it in thermophysics that much. We use something called the Kelvin scale. Now, Kelvin scale, Kelvin is a scientist that discovered at 0 degrees Celsius that the particles had some pressure. All right, so he decided to see when is this pressure is gonna go or tend to be zero. So I kept on decreasing the temperature until he got the absolute zero, which is negative 273 degrees Celsius. That's where the pressure were basically zero, or we could say is where the particles have minimum kinetic energy, which is the absolute zero. Call this what? The absolute zero. You need to know how to convert between Kelvin and degree Celsius scale. So if you've got for example, a temperature of 17 degrees Celsius and you want to get it in Kelvin, so you just simply add 273. So that's going to give you 290 degrees Celsius. And same for the Celsius scale. Okay. Now we're going to move to the idea of change in state when it gains some energy. So we know we got solid, liquid, and gas, right? So for this example, if you look at this graph, you've got the temperature and you've got the heat supplied, right? So let's say this solid, basically ice, it was a 0 degree Celsius. So we start to give it some energy. As you could see, as the energy increases, also the temperature is increasing. And then at this point, the temperature stayed the same, whereas there's a change in state happening, right? So that solid gained energy, now it's changing state. Now it became liquid. The temperature is going to increase, and then again the temperature is constant in the change in state, and now it's all gas, right? So why in these sections are the temperature constant? Because all of the energy is being used to break the bonds between the molecules, right? So the temperature stays constant. All right, so that's why you should know. Also, this could be in the opposite direction. So the gas could be losing temperature. So at this point, it's condensing, turning into liquid. And now the liquid is also losing temperature. And then now it's freezing, it's becoming a solid. And then now the solid is even becoming with a lower temperature, and so on. So this could be in reverse. So you should watch out to the changes in state. So if you look at this, this is how matter changes. So if you want to go straight on from solid to gas, this is a process called sublimation. You're not going to be really asked about this, is more in chemistry, but you could be asked for the idea of gas turns into a solid. This is deposition. And then from solid to liquid, that is melting, liquid to solid, that is freezing. And then if you're going to go from liquid to gas, that is evaporation. And then you want to come back from gas to liquid, that is condensation. You need to know the common definitions for melting point, freezing point, and so on. So study these well. And that was basically the ideas of temperature, states of matter, change in state, and Brownian motion altogether. Thank you.